Recording started.
Okay, hi everyone. Welcome to our review of the midterm exam. And if you look at the first page here, it's got a really interesting picture. And what it is it's supposed to represent space junk. And so I'm just going to read a little bit here about space junk. So, you know, once in a while astronauts get a little bit clumsy and they might drop something when they're up in space, like maybe they're working on something and they've got a screwdriver. Or sometimes parts just break off, like you've got all these satellites, you know, spinning around the Earth, and eventually they wear out. And so there's actually tons and tons of space junk that is around the Earth, surrounding our atmosphere. But what happens is space junk can get sucked into the orbit of a planet, and when that happens, the force of gravity that's associated with that planet causes the space junk to whip around at an incredible speed. Actually thousands of kilometers a second sometimes, which can be about 17 times faster than the speed of a machine gun bullet. So at that speed, even a tiny little speck could do some really serious danger. So that's basically what space junk is all about, and like I said, it is becoming a bit of a concern. So we're going to go to the next question, and just you guys can answer that. So these are going to be the purple space junk. Purple questions, I should say. So the question says, explain why space junk can be dangerous. So how would you explain that? What is it about space junk that makes it dangerous? Okay, could hit a space shuttle, that's right. Could hit a window. I see Ashley's typing as well. They move so fast they can cause a lot of damage. That's right. So even though it's a really small mass, it's the speed. Speed kills, right? You've heard that before? All right, so on to the next question. We see all these different pretty looking galaxies. They're pretty awesome looking, eh? And so galaxies come in all shapes and sizes. But the question is, what are they made out of, and where did galaxies come from? So, you know, personally I believe God put them together using ingredients He'd already created in the universe. So what were those ingredients? Well, He used stars, gases, and dust, and then He used the force of gravity to bring all those three things together to create a galaxy. At least that's what people believe. Hey Cody, how's it going? Cody's our resident Vancouver Canucks fan, right? I think there's actually a few on the school. Yeah, if I'm not mistaken, I think the Canucks have just pulled ahead of the Calgary Flames. I think they are the best Canadian team at the moment. And unfortunately, there's no doubt that the Oilers are the worst. Well, I wish it wasn't the case, but they're stinking pretty bad. They might actually make it to the very bottom of the league if they're not careful, eh? And some people are blaming it on their goalie, but because their goalie's not so experienced right now, they're waiting for their other goalie to get back in the game. But other people say, hey, their defense has to hold things up. So, oh, pretty close, eh? And am I right that Vancouver has a guy who's got the most points in the league? Is that one of the Sedin brothers, or is he on another team right now? Ooh, good stuff. Yeah, I think Sweden's going to make a run for it in the Olympics, so it should be pretty cool. See what happens. So hey Cody, this time, at this point, we're not breaking into the two groups like we did last time. We've got three people, but we've already gone over another question, so if you want to look at the recording later on, you can check that out. Oh, don't have many Canadian players, that's right, eh? Yeah. So Cody, what we're doing at this point, we're just talking about this question relating to galaxies, and we've talked about the fact that where galaxies came from, at least where people believe they came from, is, you know, originally there were stars, gases, and dust, and then the force of gravity was used to squeeze all these things together. And again, personally, I believe that God put the stars, gases, and dust there in the first place, and then may well have used gravity to squeeze those things together. Okay, so we're going to go on to the next question, and the questions are always going to be in purple. So just see who can get it. So what 4 ingredients were used to create galaxies? And please notice that I'm saying 4 ingredients. What would you say? Okay, dust, stars, and gases are 3 things. There's one other thing that's kind of like the glue. What's the glue to put them all together? I know it's kind of a tricky question that way because some of those things are things, but this other thing I'm looking for is not really a thing. Energy, that's right. And I see Cody's typing something as well. Okay, maybe not. Okay, so what I was looking for as well was gravity. So gravity is what put all those 3 things together. Okay? So now check out this picture here. It is really cool, I think. I can't remember exactly what these things are called. I'll have to check that out, but they're really cool. These images, you might have seen images like this before. These are images that are taken with the Hubble Space Telescope. I remember reading an article about the Space Telescope, and the way they designed that thing was, it's just an incredible telescope. The glass lens had to be so exact on it that if you compare the lens to like the whole coastline of Florida, there could only be a amount of variation on that lens of like 2 inches or something compared to like the whole coast of Florida. I don't know, maybe that's not right, but whatever it was, it had to be so exact. And at one point, the Hubble Space Telescope, they had problems with it, and they actually had to fix it, and they said that they were putting glasses on the Space Telescope to fix it. It wasn't exactly the case that it was glasses, but it was kind of like that, the way they fixed it, so it was kind of cool. But anyways, these are images of clouds of dust and star formations that are millions of miles away, and taken by the Hubble. I'll show you a picture of the Hubble on the next page. So here's the Hubble Space Telescope. But the question I want you guys to think about is why we send telescopes into space. And the reason is because of light pollution. Alright, so I know that sounds kind of weird, light pollution, but the way telescopes work is by using the light that's reflected off of planets and stars to produce images of those planets and stars within the telescope. So as long as telescopes are getting just the light from the planets and stars to hit them, everything works great, and we can see those things. But the problem is that other light, not from planets and stars, makes it difficult to see the light that's from planets and stars. For instance, during the day, the light from the sun makes it difficult to see the light we're wanting to see. And during the night, the light from street lights and cars and houses makes it a challenge to see the light as well. And another factor is that regular pollution, just haze, so gray sky, that fogs things up as well and makes it tough to see the light we're wanting to see. So those are all reasons why telescopes are put up into space. Okay, so let's look at a question here. Ooh, that one. I'm not sure what happened there, guys. Not sure if I can reduce the size of this either. That's a really big question. I had to do something with the whiteboard session because they don't accept PDF files anymore, so I had to use a different kind of file. And I'm hoping this is only going to be this page this happened to. I should have checked out all the pages. Anyways, so the question is, 3 reasons why telescopes are put in space. Why telescopes put into space can see better than telescopes here on Earth. So what would be the 3 reasons? While you're doing that, I'm just going to see if I can find this other picture so I can put it up on the screen. Okay, so light pollution. When you say light pollution, could you be a little more specific, Mitch? Light pollution from what? Okay, so from cities, and usually we're talking about night light pollution, right? Because you're trying to look at a telescope during the night and you're getting the lights from the cities. That's when lights are on, right? Okay. Light from the sun, like Ashley's saying, that's going to be light during the day. And can you think of one other type of pollution that's going to affect how well you're going to view a telescope on the Earth? Okay, clouds. That's true, yeah. And what's something else we talked about as far as pollution? Just haze or smog, right? Yeah, just regular pollution. That's going to affect things as well. That's right. Okay, you guys got them covered. So I'm not sure if I'm going to be able to show this any better here. If you can just kind of get a general idea of this. Okay, so you were saying the atmosphere blocks the telescopes on Earth. That's true as well. Yep. Good stuff. So guys, if you guys can get kind of a general idea of what this is here, this circle is supposed to be the Earth, and ME stands for medium orbit telescope, and LE stands for low orbit telescope. Okay? And so I'm just going to read what it says here, if I can read it. It's a little tricky. Okay, sorry, let me just pull up this on another page. Just give me a sec. It'll be easier to read. Okay, it's just going to take a sec here. Okay, so I'll just read what's on the screen here. So remember that satellites orbit the Earth by traveling around and around it. And I don't know if you guys knew this, but you can get anything to orbit the Earth, not just a satellite, as long as you launch that thing into the sky at 17,000 miles an hour. That's considered the launch speed. And once you get something at that speed, and it does have to be the correct angle and stuff like that, but once you get it at that speed, 17,000 miles an hour, it will continue to orbit the Earth at 17,000 miles an hour. Okay, so how satellites work is they send information back and forth to the Earth, and as you can see on the diagram, well, sort of see, the higher the satellite, the larger the surface of the Earth that can be covered in terms of the area the satellite is able to send information to and from. Okay, so the area you see on the Earth here is the amount of area that the satellite is able to provide service to. So it's sending information back and forth to that amount of area. Okay, so again, ME stands for medium Earth orbit satellite, and LE is low orbit satellite. Okay, so if we go on to the next page, so this question says, write a sentence that helps to explain the relationship between the height of the satellite above the Earth and the amount of area covered on the Earth. Yeah, I know what you mean, Cody, about being glad the Earth is not a pyramid. Okay, so you wrote on one of the lessons last week, you showed a picture of the Space Center's window damage that could have been done by a FLEC. That's right, Cody, and that was actually what we talked about in question 1, the fact that space junk can do an incredible amount of damage because of how fast it's traveling around. So that's why even a fleck of paint could do some major damage. Yeah, no doubt. So if a satellite is far away, Ashley's saying, you will be able to see a large area, but if it's closer, it will be limited more. That's right. And so that's why the medium orbit satellite, which was the higher one, is able to deal with a lot of a larger area on the Earth. So if there were GPSs, it could deal with more GPSs. It could send information back and forth to them, the medium orbit one, whereas the low orbit one, it would only be a small number. Okay? All right, so now we've got this diagram here. It's kind of a cool diagram. It looks like a rainbow. And the lines on these diagrams here, let me just get out my little pointer here. So you can see these black lines. So these actually mean something to an astronomer. An astronomer looks at this kind of a graph and says, you know, hey, this I can figure out. So this is called a spectrograph, and what happens is these lines actually match up with known elements. So sodium, helium, and hydrogen. Those are actually some of the elements that are found in stars, especially helium and hydrogen. And you know, on the sun you actually have like a hydrogen bomb reaction going on. Yeah, it does look like a rainbow, totally, eh? Okay, so that's one of the things that they can figure out. When they see lines on a graph, when they're looking at a certain star and it produces one of these graphs, they're able to tell which elements are found on that star. That's one of the things they can find. They can find two other pieces of information as well. They can find out whether objects in space are moving toward them, like toward Earth, or away from us, and also how fast these objects are moving. And I don't know if you guys remember, we talked about the Doppler effect a little bit. I don't know if you guys remember that term, the Doppler effect. That's what they use to figure out whether objects are moving toward us or away from us. Like if you're listening to an ambulance, the sound of the ambulance is different when it's moving toward you than when it's moving away, because the sound waves are compressed when they're moving toward you, but as they move away from you, they're spreading out. And it's the same principle that it's working on when they're able to use these kind of graphs to figure out whether objects are moving toward us or away from us, except instead of sound waves, it's light waves. Okay? So let's check out the question for this one. The question says, list three things that the lines on a graph, I should have said a spectrograph, can tell astronomers about stars in space or other objects in space. Yeah, that's right. Okay, so that's going to be for the next question, the sunglasses here. So what are the three things that we figured out these graphs can be used for, these spectrographs? Three things that astronomers can learn from them. The heat of the stars. Yeah, kind of the heat of the stars based on the elements that are contained in them, right? So you're right, we didn't really talk about that exactly, but based on the elements that are contained in them, they can actually be used to determine how hot the stars are. That's right. And actually saying whether a planet's moving closer or farther away. And also there's one other thing about the planet's movement. Do you guys remember what other thing they can tell us about the planet's movement? Not only if they're moving closer or farther away. Remember what the other thing was they can tell us about a planet's movement or a star's movement? Okay, they can also tell us the speed that it's moving at as well, right? In addition to whether it's moving toward us or away. Okay. All right, so what we're going to talk about now, yeah, exactly. It's like police officers with their radar gun, eh? So, the sunglasses here, I just put those up and I asked the question, you know, what's your point of view? So, I don't know, have you guys ever heard where two people have experienced the exact same experience, like a car accident, and then they tell stories, and you just kind of wonder to yourself, were those people actually at the same accident? Because their stories are so different, right? Because all of us tend to emphasize one thing or another. Yeah, it reminds me of a Mythbusters episode where they were trying to outsmart the radar gun, and it was very, very tough to do that.
Goodbye.
Whoa. Just got kicked off the stool. Just give me a sec here. Okay. Okay, so guys, yeah, so when you're talking about like point of view or perspective, yeah, goodbye. Point of view is kind of another word for, or perspective is kind of another word for point of view. And I'm just going to tell you three different examples to illustrate different perspectives that people can have. So you guys might have heard the term economics before, the social studies. So economics has to do with money. And so if you ask the question, how can I make more money out of this project I'm doing? Excuse me. That's an economic perspective, right? Whereas a moral perspective comes from the point of view, is this action the right thing to do? And last of all, an environmental perspective looks at something in terms of, is it good for the environment, right? Okay, so those are three different kinds of perspectives. Oh, I got another one of the big screens, guys. Okay, I'm really going to have to check this. Because for some reason it's just doing it once in a while. Okay, so I'm going to use my little screen on my computer to figure out what this question should be. Just give me a sec here. Okay, so I'll just read these for you. And actually, why don't I see if I can paste them here into some, if there's any space left over for me. Okay, so here's what the question should say. There we go. You guys can read that okay? You're joking, right? Please tell me you're joking. Is it really small? Are you serious? Too small? Ah. Is it small for all you guys? Can you read the part where it says for each of the following perspectives? Can you read that okay? You can read the big one, but you can't read the small one? Okay, I'm just going to read them for you. So the first one says, part A says, okay, so it says, for each of the following, state whether the opinion expressed represents an environmental, economic, or moral perspective. So part A says, people should explore the South Pole in order to learn new things that will benefit mankind. What do you guys think? Would that be environmental, economic, or moral? That's right, that would be moral. Okay? So the next one says, the South Pole has some rare species of plants and animals that should be studied better so we can learn how to preserve them. What would that be? All right, you guys are rocking here. And the last one says there are rare deposits of minerals. Yeah, go us. You guys are on the same team this time. There are rare deposits of minerals found near the South Pole which can be mined so the minerals can be turned into useful products. What would that be? Economic, that's right. Good stuff. Okay, so I'm really hoping we don't have too many of those really, really big pictures anymore. All right, so got the next screen here. Kind of cool screen. It comes from your textbook, although I found it on the internet as well. I think it's almost identical to what you see in your textbook. I forget what these are called. It's some fancy name anyways. But it shows both the brightness of stars and the temperature of stars, right? So what's kind of interesting about these diagrams, normally you think about orange as being really hot, and you think of blue as being cold, right? But in actuality, if you've got a blue planet, that's a hotter planet than a yellow or orange planet, right? The other thing you notice if you look on this graph is the higher you go, the larger the stars are. So these ones are really big stars. They're known as supergiants, whereas this little white dwarf star is your small one. Okay? So, on to the question. Ah, good. Put the small text again. I gotta figure out what's causing that. Anyways, all right. So, yeah, the battleships are going to be about the next question. So first of all, the question here says, oh, Spanish accent. Well, I can do Mexican, but I'm not sure if it's that good. I can say, "Hey, mister, you want to buy my sister?" I don't know. Spanish, Espanol. No, I don't know if there's any difference between Spanish and Mexican. Too bad you guys don't have your mics. You could do something here for me. ¿Cómo de llamas. Okay, I don't know what that means. What does that mean, Ashley? What's your name? Okay. Comment t'appelles-tu? Where'd you learn that, Ashley? Did you go to Mexico, or? Oh yeah, you are going to Mexico, right? When are you going there again? Ah, very cool. Should be fun. How about with San Lucas? Is that in Mexico as well, Cody? Wow. That must be nice, guys. I've never been outside North America. Oh, well, actually, I guess Mexico kind of is North America, isn't it? But I've never been outside Canada and the U.S. Costa Rica, oh my goodness, that would be nice. Rainforest. Ah. You guys, I would like to come. Pack me on the plane. Anyways. So guys, on to question 7. Oh yeah, I heard you can go on zip lines through the forest of Costa Rica. Is that what you were doing, Mitch? That would be beautiful. Totally awesome. You can avoid the spiders and snakes that way, eh? Cody's going to the game. Man, guys have good stuff going on. Well, I'm going to Westwood Water Park at the end of the month. So there. Yeah, we got a good deal. Sometimes they have good deals where it's like $7 a person sort of thing. So it's really good. It's nice. All right, so guys, question 7. Part A, it says, in terms of temperature and size, how would you describe a white dwarf? So how would you describe the white dwarf in terms of both temperature and size? Yeah, back to science. All right, so the white dwarf. Who can tell me? Look at its name for the size. Is it big or small? Okay, and can you guys remember if it's hot or cold? Do you remember what the color was from the diagram? Okay, well, actually, the white dwarf was actually hot. Because if we look back on the screen here, so you remember, temperature, this is temperature, right? This is 40,000 degrees, and so the white dwarf is actually going to be hotter, right? And this is cooler. So remember, blue is actually hot. All right. So, how about the supergiant? Is it big or small? I guess that's too easy, eh? The name pretty much gives it away, doesn't it? Okay, so it's big and it's cold. That's right. All right. So now we can do the battleship stuff, which I played with my kids recently. I played with my father-in-law, and he had like an uncanny ability to guess these things. Like he made about, I forget how many different, like when you add up the size of the battleship things, one of them's 5, the other one's 4, 2 of them are 3. There's something like 17 different things you can put in them. And my father-in-law only guessed 25 times. So he only missed 8 times or something like that. Okay, get with the plan here, guys. So, you guys have probably played Battleship before, right? And so you guys know that these things are called coordinates, right? Like when you're talking about something like A5 or G8, those are coordinates, right? Just like in math, you have coordinates, you've got X and Y coordinates, right? So in space, there's another kind of coordinate that lets us determine the position of any object in space. So let's look on the next page. Okay, so these two things, you guys might remember these azimuth and altitude. So instead of like x and y, we've got these two things. Okay, so again, azimuth is the same as compass direction. It starts with 0, and then 0 is north, and then as you go east, that's 90 degrees. So just imagine a clock going around, okay? Then when you get all the way to west, that's 270, all right? And 360 degrees is just before you get to 0 again. Okay, so that's azimuth, compass directions. Altitude is just how high it is, right? And that's from 0 to 90. And if it's on the ground, the object's on the ground at 0 degrees. If it's directly overhead, then it's 90. Okay, so that's how we get directions with those two coordinates. And if we look at the actual question here, so this question says, using descriptions for azimuth and altitude, how would you describe an object that is, number 1, midway between south and west as far as azimuth, and number 2, midway between the ground and directly overhead as far as altitude? So what do you think about, even if you break the question into the two parts, what would it be as far as midway between south and west? How many degrees would that be? Okay, so Ashley's saying it's going to be 45 degrees, okay, and 225. Okay, so if it's midway between south and west, let's just look at a quick circle here, right? Okay, so 0 degrees is going to be up here, right? Then we get to 90, 180. That's going to be south. West is going to be here. That's going to be 270, right? And then midway between 180 and 270 is going to be this here, 225. Okay, so that's the compass direction. And then between 0 degrees, which is just flat on the ground, and 90 degrees overhead is going to be 45. So Ashley's right, it's going to be D. Good stuff. So does that, guys, does that make sense to you? How we get that answer? Okay, right on. Okay, so since we were talking about pets earlier on, we were finding out the zoo that Ashley keeps at her house. Here's a picture of all different breeds of dogs. You know, sometimes you look at all the different dogs that are out there and you say, man, how can a poodle be a dog and a Great Dane be a dog? They look so different, right? It shows how much potential there is in their DNA. And, okay, so variation refers to the fact the creatures are different from another. Some are big, some are small, some have tails, some have no tails. Now, when you're comparing dogs, because dogs are all the same species, that's what you call variation within a species. If you're comparing like a poodle and a snake, that's variation between species, right? Okay, so the question we have here, oh, here we go again. All right, I'm just going to find this one and paste it up on the screen. Yeah, don't worry, next time I will, I'll figure it out ahead of time to make sure it's not so big. Okay. Okay, I hope everyone can see this. I'm going to try to make this bigger, so. Okay, can everyone see this okay now? You guys must be seeing some, oh, you see those big bugs on the screen. Okay. Okay, can you guys see question 9 okay on the screen? Okay, so this question says the difference in height between chimps and apes, is that variation within a species? What would it be, true or false? What do you think, Cody? Cody, did you say true as well? I saw you wrote yeah, but I wasn't sure if that was from before. Okay, actually Cody's right. That's actually false, because this is between species, because chimps and apes are different species, right? Does that make sense? If we're looking at variation within just chimps, then it would be true. But since it's different species, this is variation within species, or between species, not within. Okay? They are they are all what you call primates, but they're not all the same species, right? They might be part of the same family. If you guys remember when you talk in, we used some sort of acronym, I think it was like King Philip can only find giant spiders, and King stands for kingdom, P is phylum, and all that kind of stuff. And at the end of it is spiders, which is species, right? And so when you're talking about variation within one species, that's talking about like just chimps, right? Okay, so you guys were probably wondering about those beetles here. So all those wild beetles. So I'll just read what should be on the screen for the beetles here. So I know it looks really weird when they're made that big. Okay, so you guys have probably heard the expression before, variety is the spice of life. And it's true, because I mean, you know, I like chocolate, but I wouldn't want to have chocolate all the time for supper. I like to have a variety of stuff, right? A few veggies, some meat, that kind of stuff. So diversity is just another word for variety, right? And biodiversity means there's a lot of different creatures living in the same area. Now, do you guys know what conditions in the world produce the greatest biodiversity? How would you describe what the conditions would be that would produce the greatest amount of biodiversity in the world? Think about what part of the world would have the greatest amount of biodiversity. Okay, well, the rainforest, right? You know, people often say that the rainforest have, you know, with some sort of species of creatures like plants and animals, the rainforests have more than half of all the different, I don't know if it's plants, it might even be beetles. Maybe the rainforests have more than half of all the beetles that are on the earth. I'm not sure if that's true, but there are some different species that's true. So how would you describe the conditions in the rainforest? Okay, so a lot of moisture, and what else? Moist and what else? Okay, you'd also say hot, right? They're really, really hot. It's like a steaming jungle, right? Okay, so places that are moist and hot give you the most biodiversity. So, with that in mind, what do you think the answer would be for question 10? Which of the following locations would contain the greatest amount of biodiversity? That's right, it's going to be Brazil, South America, and the rainforest. Good stuff. Okay, well, fortunately, we've got the next thing here is not coming up huge. Yeah, we'll get to the Roadrunner in just a sec. So what we're just going to talk about is just the difference between natural selection, so that's where nature selects the traits of organisms. Artificial selection is when humans select the traits of organisms. So, for instance, we might select dogs that are more friendly or maybe have certain skills like keeping sheep in a pen. And so natural selection is when nature selects traits, for example, creatures that are faster than others. So, you know, like the Roadrunner, for instance, faster than the coyote. He can never get him. I don't know if you guys are still able to catch that on TV. I used to watch that all the time when I was a kid. Yeah, I don't get it on any channel that I have, but oh, you don't have TV? But yeah, classic cartoon. I wish they still had cartoons like that. Oh no, here we go again, guys. I'm sorry, but I will paste the question up here. Give me a sec. Okay, so here's the question in slightly smaller version. Okay, can you guys see that okay? Okay, so this question says if it's natural selection, you write 1. If it's artificial, write 2. Okay, so can somebody tell me what the answer would be writing a 4-digit number? Okay, so 1, 2, 1, 1. So Ashley's saying that some birds having a unique shape to eat certain kind of seeds, that's going to be natural selection. So nature chooses which birds live and die based on having the right shape for the right seeds. That's true. Cows having a larger amount of milk, that's usually we're thinking about artificial selection. People are choosing that, right? The one with plants having a higher resistance to certain diseases, that one, actually that's kind of ambiguous. I don't think I'd give you that on a test. I shouldn't, because that one could be something that just happens naturally, or a lot of times plants have a higher resistance to disease because they've been bred that way by people. So I think that one could be either one. I'd have to accept both for that one. Rabbits living in cold conditions having longer fur, that would be natural selection. Computer is wrong, I said it before. All right, so on to the next one. We've got another mutant, another huge question here. So, all right, so I'm just going to paste this on here. Okay, there we go. Okay, this one, guys, I'm not going to really do any explaining for this. I just want to see if you guys can get it, okay? So we've got 4 different possibilities. Maybe I'll need to make it just a bit smaller. There we go. I think that all fits on there, does it? Not quite. Okay, pretty much does. So we need to match up the statement, right, with the number here. So the first thing we're looking at, I want you guys to tell me if it's mitosis, fertilization, meiosis, or embryo. Okay? So those are the 4 choices. So the first one, guys, the union of male and female gametes, egg and sperm, which is the first state of sexual reproduction and represents the beginning of a new human being. So do you guys think that's mitosis, fertilization, meiosis, or embryo? That's right, fertilization. Good stuff. Okay, number 2, a zygote formed by the union of gametes experiences multiple cell divisions until it forms a multi-cell structure. Okay, embryo. Good stuff, right? Because the zygote continues to divide and eventually becomes an embryo, right? When it's many, many cells. Okay. So number 3, the division of a cell for the purpose of growth and cell repair resulting in daughter cells which are identical to parent cells. Same amount of DNA. Do you think that's mitosis or meiosis? Okay, that's right. Mitosis is just regular growth and repair, and that's when you've got the same amount. Okay, so for the last one, division of a cell for the purpose of sexual reproduction resulting in daughter cells with half the DNA, that's meiosis. Okay, so meiosis, sexual reproduction, mitosis, just regular cells are just growing or repairing themselves. Okay, on to the next one. I'm really hoping this one is going to be a nice size, but it's not. So the thing is, guys, I tried this out in the beginning, but when I tried it out, it all looked good because, like, I just looked at the first couple screens and they looked good, but I should have looked at the next ones. So, anyways, what we're going to do here, we just had a picture of the peacock, and we're just talking about the differences between sexual reproduction and asexual reproduction. So again, asexual reproduction when you don't have any parents involved. And so we're just going to look at the pros and cons of each one, right? So pros of sexual reproduction: 2 parents means kids are different from their parents. That gives variation to the population, and so if the environment changes, someone in the population will likely have the traits they need to survive, right? But on the downside, sexual reproduction takes time and energy, time to find a mate. Few organisms are produced, okay? So those are the downs. And then as far as asexual reproduction, here I'm just going to go on the next screen and see if that one's okay. It's not, so I'll just continue on. Asexual reproduction, some of the advantages: you have large numbers produced, for instance with bacteria. It doesn't take very much time and energy. And a downside of asexual reproduction is all creatures are similar or the same, so if the environment changes, they might all be wiped out by the environment. Okay, so let's look at the question then. Okay, so just ignore these guys for the moment. So the question here: bacteria use asexual reproduction to reproduce while black bears use sexual reproduction. Okay, so there's some different statements here, and I want you guys to tell me which of these statements, 4 statements, are going to be an advantage of the method of reproduction used by a bacteria. So which of the 4 would be an advantage of asexual reproduction? Okay, who can tell me one, guys? Okay, Ashley's saying 2 and 4. So bacteria produce large numbers of offspring. Okay, that's good. That's an advantage of asexual reproduction. And number 4, reproduction of bacteria requires little time and energy. Good. That's another advantage of asexual. Now, number 1 would not be an advantage because the fact that they're identical to each other means that if the conditions change, they can't really adapt. Okay? Good stuff. All right. Well, if you have to go, Cody, you can just catch the rest of it on the recording. Okay. So just catch up with us in a bit here. We better move along here so we can get all covered, though, okay? All right, we'll just catch you in a bit then. So this is, at this point we're just talking about heredity, right? So you look at these 2 guys, they look pretty similar, right? And so the son looks a lot like his dad. So the son's inherited a lot of his dad's looks. On the other hand, if you're talking about non-inherited traits, these are traits that we learn during our lifetime, right? So if both father and son can speak Japanese, that's going to be a non-inherited trait. So, going to the next page. There we go. The big screen again. Okay. So let's see if we can actually read it here. We can actually read these 2 here. Okay, so right number 1 if it's a heritable trait, and 2 if it's non-heritable. So Judy has blue eyes like her mom. Would that be number 1 for heritable or 2 for non-heritable? Okay, that's heritable, that's right. And Eric is a fast typist like his dad. That's 2. That's non-heritable. Good stuff. All right, now the next picture, you guys can basically see it, right? Well, mind you, there's some other stuff underneath, too. All right. Let's see if we can get it all on the screen here. I think pretty much. Let's see what the first thing is. Give me a sec. Okay, the first thing's supposed to be a shark. So we got kind of half a shark, right? Okay, so shark eats the sea lion, eats the large fish, eats the small fish, right? So guys, if you ever have a question that has to do with like a food chain, it's always good to draw out the food chain, because then if you have changes in one of the members of the food chain, you can make predictions on what's going to happen to the other members. So let's take, for instance, this one here. What do you think would happen if, okay, I'm just trying to read this here. It says, what would happen to a large fish population if the sea lion population was affected by a fatal disease? Okay, so we'll look at it again. Okay, so sea lions get a fatal disease. Okay, good to see you back, Cody. Okay, so if you look at the diagram, if sea lions have a fatal disease, what's going to happen to the large fish population? That's right, it's going to increase. They're going to have less predators. And so what's going to happen to the small fish population? Okay, that's right, the small fish numbers are going to go down. So again, it really helps to just draw it out and you can see the relationship that way. Alright, so we'll go on to the next question. Oh good, there we go. We got it small again. So, the question here says, in a forest ecosystem, deer feed on bushes and they have wolves as potential predators. If the sickness among wolves reduced the number of wolves in a wolf population, what would happen to the number of, or the amount of bushes as a result? Okay, so Ashley says that the bushes are going to decrease. Mitch says they're going to increase. Ooh, we got a little suspense here. Let's find out. So, let's just set up a diagram here. So, deer feed on bushes. Okay, sorry. Wolf feed on deer, first of all. Wolf feed on deer, which feed on bushes. Okay, so the question says that wolf numbers are going to go down. So I'm just going to write down. Okay. So because wolf numbers are going to go down, deer numbers are going to go up, right? Because deer numbers are going to go up, they're going to eat all the bushes. There's going to be fewer bushes left. So bushes are going to go down. So does that make sense that bushes are going to decrease? Okay, so that's where, again, just drawing a diagram out can help. Okay, so we're just going to quickly review again some acid-base related stuff. So you guys remember acids are a low pH, bases are a high pH. If it's 7 right in the middle, it's neutral, like water, right? And a strong acid is something like 0. A weak acid is 6. And same thing with bases, right? And acids and bases neutralize each other. Remember, that's why we take something like Tums. And when we have a neutralization reaction, we add acids and bases together, and it produces salt and water. And salt and water are together, they're going to have a neutral pH. Okay, so we'll look at a question on this one. Okay. So, I think we might have had this question before. So it says the graph shows what the pH looks like in someone's stomach after taking large amounts of TUM, which are base. Okay, so you're adding more and more base. And so the question says which amount of base would represent the correct amount to take in order to relieve a stomach acid problem. Well, remember, we want to have a neutral amount of base, a neutral amount of acid and base. Okay, so Ashley and Cody are both saying 10 grams, and that's right, because that's going to give us a neutral pH, which is going to be 7. So the correct amount is going to be found wherever pH is 7, so it's 10 grams. Okay, so the amount of base is going to be C, 10 grams. Okay, so you said it originally, right, Mitch? Mitch is trying to cover his bases here. Ah, not again. All right. So, so guys, this here is showing us, or what it's trying to show us, it's trying to talk here about the difference between organic substances and inorganic substances. The main difference is organic substances have carbon in them, right? and so they usually have carbon and hydrogen, whereas inorganic do not have carbon. Oh, we lost Cody. All right, so let's go on to the question then. All right, so the question is, state whether NaCl is an organic or inorganic substance and explain your reasoning. So what do you guys think? Is that organic or inorganic? That's right, it's inorganic because it doesn't have any carbon. The Cl is actually not, the C doesn't stand for carbon, right? Okay, so moving along, guys, we're just going to go over, you guys might remember this before, we talked about what happens when a lake dies. There's a few different steps that happen. So first of all, you add some sort of chemical that has both phosphorus and nitrogen, you know, so for instance, a fertilizer. And because you have those chemicals, you're going to have a lot of algae growing, and initially, in the beginning, you're going to have a lot of photosynthesis. And because you have photosynthesis, oxygen levels are going to be high, right? Because photosynthesis produces oxygen. But eventually, step 3, the algae are going to die, and then when they die, bacteria are going to feed off them, and at that point, the bacteria use up a lot of oxygen, and so now at this point, the fish don't have enough oxygen, and so they die. So, we go into the question here. Okay, well, I guess we can make out this, right? So the question says, what is the cause of each of the following? So first of all, what's the cause of the growth of the algae? What causes them to grow? Okay, it's two things. It's nitrogen and phosphorus, right? Those are the two things that are in the fertilizer? Okay, and so why do we have high oxygen levels in the beginning? You guys remember why that is? What's that process that's going on that's producing high oxygen levels? It's something the algae are doing? Photosynthesis, good stuff. And why do we have the fish die in the end? Oh, okay. So, Mitch, are you up to speed on what the question is here, or did you miss part of it? We're just talking about the different steps in, you know, what happens with the death of a lake, sort of thing. You add the fertilizer in the beginning, and why is it that the fish die in the end? What causes that? Okay, remember it has to do with low oxygen. What causes low oxygen? You guys remember what it is that produces that? Okay, so basically what's happening is the bacteria that feed on the algae are using up the oxygen, and that's why the fish die eventually. Okay. I think, Mitch, you're saying something about fast-moving water produces a lot of oxygen in the water. Is that what you were meaning there? Yeah, that's right. Okay, so we've got another question here. A little bit difficult to see. So I think what I'm going to do, guys, because I can't really paste this question on here, I'm just going to explain to you what the answer should be. So this one here says, we're looking at the dissolved oxygen levels over time. So the question we have is, which lake is going to be showing algae growth and which is going to be, okay, either bacteria growth followed by algae growth or algae growth followed by bacteria. And so the correct one should be this lake right here should be showing, first of all, algae growth, right? This is the oxygen levels. So first of all, algae are growing. As they grow, we have high oxygen levels, right? It's growing. Eventually, the oxygen levels taper to 0, and then they go down eventually because of the bacteria using up the oxygen. Okay? So this is algae growth, first of all, followed by bacterial growth. All right, so we're getting close, guys. And, oh, thank the Lord. Now we got small text again. Great stuff. Okay, so we got, what we're talking about here is LD50 values. So do you guys remember anything about those things, LD50 values? Basically, LD50 values have to do with how toxic a substance is, and what it actually means. An LD50 value is when 50% of the creatures will be killed, and you multiply the LD50 number by the weight of the creature. And you guys might remember from before that it's actually the lower LD50 value. The lower the LD50 value is, the more toxic a chemical is. Okay, so if you look at these two LD50 values for poisons, so you look at the first one for carbamate, they're both different types of carbamate, okay? So if we look at these two ones, think about which one you think is more toxic than the other one, because we're going to have a question based on it. Do you think the first one's more toxic or the second? First one starts with an A, second one starts with a C, right? So let's look at the actual question. Okay, so the first question says, what is the meaning of an LD50 value? So what do you guys think?
Have you now?
How would you describe what an LD50 value is? How much chemical is needed to kill something? And if we put together what both of you guys have said, how much chemical is needed to kill 50% of an organism, right? Okay, that's an LD50 value, good stuff. And do you guys remember which of the rat poisons would be the most toxic? Remember if it's the first one or the second one? Okay, let's go back. That's right, it's going to be aldicarb. It's going to be more toxic because it has a lower LD50 value. That means it needs a smaller amount of chemical to kill 50% of the rats. Okay? So smaller, lower the LD50 value, more powerful the chemical. Okay. So, next question here. Okay, we'll go back to this page, which we can see, fortunately. So we're looking at two different kinds of indicators here. And when we talk about microbial indicators, we talk about things like bacteria, right? E. coli is a certain type of bacteria that causes a lot of health problems. If you find E. coli in the water, you know there's problems in the water, right? Whereas if you find one of these guys, which are called aquatic invertebrate indicators, it doesn't mean there's problems in the water. All it means is there's a certain pH in the water. So for instance, if you found one of these guys, mayfly, it might mean, you've got a pH of 7 or 6 or something like that, Or it might mean that the water is warmer than normal, that sort of thing. Okay, so that's what these guys mean, these aquatic invertebrates. They don't necessarily mean water is polluted. They mean that it's just a certain temperature or a certain type of acidity. Okay? So, if we look at the question then, we've got Jim testing water, and he finds in two different lakes. One lake he finds E. coli bacteria, the other one he finds a dragonfly nymph. So let's just look at the second part of the question. What conclusions would he draw on each of the lakes? So what conclusion would he draw about the lake where he finds E. coli? Okay, so if we find, okay, so it's bacteria like E. coli, it's contaminated lake, and if you find one of those other guys, the aquatic invertebrates, what does that mean? Does it mean that the lake is necessarily polluted? Yeah, if it's an aquatic invertebrate, like one of those little guys you saw before, like a mayfly, it doesn't mean that it's polluted. It just means that it could be either warm or cooler, or maybe a pH of 6 or a pH of 7. Okay? So that's the type of thing we're looking for. All right, we're very close. Last question.
You have new mail.
Okay, sorry, I just got to check my mail real quick. All right. So the last question here is a little bit tricky to make out, but I'll just read it here. It says, some tropical fish prefer an environment that is slightly acidic. I know it's kind of loopy seeing things move around here. Based on this info, what do you think would be the most likely concentration of these fish, number of fish, measured in millions of kilometers of water, millions per kilometer of water? Okay, and see what we do here. Basically what we do here is we would read off the screen. So if it's asking us to find the concentration in millions per kilometer, so we need to find out the concentration that's going to be on the bottom of the scale, and the question tells us they prefer a pH that's slightly acidic. Okay, so slightly acidic can be maybe a pH of 6, right? So we would look here on the screen, we would find a pH of about 6, and we would read that, and that's going to give us a number of 20 for the concentration. Okay? So, guys, I want to apologize for the fact that this text has been, big and small and that kind of stuff. Next time I'm hopefully we'll be able to figure out ahead of time. All right, well, thanks for your patience, guys, and thanks for your good participation. Good, I'm glad that it helped you guys. Sorry we didn't have the wild, kind of hockey game that we had last time. Maybe we'll have a few more out next time and we can do that again. All right, well, I better let you guys go for lunch, and so hope you guys have an awesome day. And yeah, Ashley, have fun with your pets. And Mitch, have fun. Where is it you're going to again? Or was that Cody who was going somewhere? I can't remember. Ah, renovating, hey? Good stuff. All right, well, take care, guys, and since we're really close to the weekend, hope you guys have a great weekend as well. Okay, bye for now.